For Unit 2, Day 1 notes, relations and functions. So a relation is a pairing of numbers in one set called the domain, with numbers in another set called the range. A relation is often represented as a set of ordered pairs, which are x, y. So when you see this on a graph, it's like any graph that you see. Any picture on a graph, that's a relation. Now these words here are synonyms: x value, input, independent variable, and domain. All of this is your x coordinate. For the y value, output, dependent variable, and range, this would be your y coordinate. And then lastly, a function is a relationship that pairs each input value with exactly one output value. Okay, for example 1, identifying functions using mapping diagrams. So first, we need to identify the domain and the range of each function or each relation. Represent the relation with a mapping diagram, which is this part here. And then you want to answer the question, is the relation a function? So for your domain, you're looking at your x values. Okay, and I want to write this in set notation, so I want to have these little braces right here, just like I was given in the ordered pairs set notation up here. So I look at my x's, -2, 0, 4, 5. I'm going to jot those down. I put a comma between each one. I make sure I have the open and the closed brace. Okay, so this is representing set notation. You do not have to have these numbers in order, but I do like for you to have them in order. For the range, we're going to look at the y values. And I see that 0.5 is my smallest one, so again I'm going to have that brace right there. Then I can put 0.5. If you want to put a 0.5, it's the same thing. Then I have two 2.5s. I'm only going to write one of those. I don't write it again if it repeats. I just write it one time. And then I have 6.5. So now in the domain, in the mapping diagram here, I'm going to list these numbers. And over in the range, I'm going to list those numbers. Again, don't repeat numbers, just write it one time. And then up here in the ordered pairs, I say -2 maps to or goes with 0.5. So I would draw an arrow from -2 to 0.5. And then 0 goes to 2.5 or maps to 2.5. 4 maps to 6.5. And 5 maps to 2.5. Now, in this particular problem, none of the exit value is repeated. So this is a function. And the reason the x's did not repeat. Now, in this particular example, it doesn't ask you to explain, but just because it is notes, I want to make sure you understand why. So the x's did not repeat. That means it is a function. For part B, we're going to find the domain, so those first values in the ordered pair again. And I'm going to again write them in least to greatest order. So 4, 5, and then I have 2 6's, but we don't write the repeating numbers. We just write it one time. And then for the range, we have 5, 3, 4, and 8. So I'm going to go with 3 first, 4, 5, and then 8. Remember that we have to have those braces there to show set notation. Then for domain, I just fill in the 4, 5, 6. For the range, we have 3, 4, 5, 8. Now, I'm going to go up here starting with 6. So 6 maps to 5. 4 maps to 3, 6 maps to 4, and then 5 maps to 8. Now, as you can see, up here, our 6 is repeated in our x value, and when you look at the mapping diagram, we see that there are 2 lines and arrows coming from 6. So this is not a function because the x is repeated. But you could say your x's or your domain or your input values, if they repeat, it's not a function.